So, welcome back. Now, that might be the last video in that session on first look at data that captures some material on principal component analysis. So, what I now want to do is I don't yet have a finance application in mind. So, I was really wondering whether I should archive that in that video here. But I still want to do it. And the reason is our friends from the science departments. Now, they use PCs slightly differently than what we use them for. What do we use them for? Last video. It's about common versus idiosyncratic movements. Identify these things. And the scientists think about people who want to recognize handwriting, so on and so forth. They have a very similar thinking. But like I have bad handwriting, all right? But if I write a number 6, that still looks like a number 6, but it doesn't look as nice as if someone else was to write it. And therefore, what these IT people, I don't know, let's just call them scientists, non-financial academics, what they care about is basically to get rid of my idiosyncratic handwriting and just stay with the pattern that looks closest to it, the number 6. Now, technically speaking, for our application here, they basically ask, what would the return panel of these 42 blue chips look like if we were to represent that as being only driven by this one PC? So roughly speaking, as one PC explains 45% on average, it just says on average, we would throw out 45% of variations for every stock on average. Some stocks move more with the market, so there we might only throw away 20%. Other stocks move less with the market, so there we might throw away 70%. And I want to do that now to show you, right? So it's for our scientist friends. Sorry. That they maybe can give us some insights on what we could do with that, and for our finance friends to see that that's what you could do, right? So we practice a little bit our thinking about PCs and rotating the original panel into a linearly transformed panel. Let's just do it. And for an application, see what's the difference between the original data and that data. So what's the heading for today or for now? PCA1 induced returns versus actual returns. Okay. Cool. If that confuses you and you're from finance, just delete the video. Right? I think that's fair to say. So here's what we do. We basically have our PC1, we have our PCA object, and now we want to make an inverse transform. Right? We take as an input the PC1, and we want to get a return panel for our blue chip stocks where every stock return is only driven by that PC1. Okay, I just therefore call that RD PC1, just in order to never ever confuse that with RD. Okay, well, what shall that be? Well, we take our PCA object, and the PCA object has a function which is called inverse transform. And the input is PC1. Now, if you want to understand the mechanics, we have a video in the PCA section somewhere. It's been quite a while since I've been doing these, but they kind of show you how you can rotate from the PCs back to the, I want to say original data, but it won't be the original data unless you use all the PCs. But if you just use one PC, it will not be the original data. But at least it's the original coordinates. That's the word I was looking for. Okay, so that's what we do. Let's just see what's inside that object, right? So we could just get the shape. All right, you see, it has exactly as many rows as we have time points and 42 columns. So these are our rotated stock returns, where every return is only driven by PC1. Okay, now let's visualize that. I want to visualize that with Volkswagen. Why Volkswagen? I don't know. Just popped up. So what do? We loaded in the matplotlib library. So that's good. We called it PLT. So now we just do plt.scatter. Give me a scatter plot. As the x values, I want the time. And I also want as the y, give me Volkswagen. Where's the mouse? Here's the mouse. Give me Volkswagen. DE. All right. And let's just change the, no, let's not do that. Let's just do that. That is Volkswagen. That will be the plot for the scatter plot. And I want also to plot on top. What would the Volkswagen return look like if we ignore the firm specific movements of Volkswagen? So we take RD PC1, which we just created recently. And the way I'm going to call that, because I doubt that is a pandas frame. I could check it, but I doubt it. I thought about doing it differently. I thought about, yeah, I see that the last asset in my panel is Volkswagen. I think that's the reason I chose it. And I ignored the one over n portfolio in my entire PCA exercise. So therefore the last column here of the 42, or here the last index for the inf op is Volkswagen. Okay, yeah, therefore I get Volkswagen by saying take all the rows and rdpc1.shape1. Yeah, but -1 as the counting starts in 0. Also plot that. And here I want that the color is a little bit lighter than the original one. So let's just see what we get. Okay, we have the dots. That's nice. That's not too bad. So let's also add a title, plt.title. So what shall the title be? That's the Volkswagen return in blue versus PC1. Yeah, that's why scientists help me. How would I call that? PC1 rotated, PC1 projected. Let's just call PC1 rotated FDE return. Okay, and that is in orange. All right, let's just redo the picture. Okay. Okay, we could make the picture nicer, that's clear. But okay, my learning point that I want to bring across is if Volkswagen was only driven by this market factor, that would performance would be this orange line. You have financial crisis here, COVID a bit here. And then you see big differences like here, the Volkswagen short squeeze. That is a Volkswagen return movement, which was gigantic. It is not captured in PC1. It's really something Volkswagen specific. All right. That most likely here is the diesel scandal, Volkswagen specific. Here in the COVID area, I don't know, it's interesting to look, but just tells me that within COVID, Volkswagen did even worse than the market. Yeah. Okay. So what could we do next? We could check the correlation of the orange and the blue line. So let's just take the correlation of Volkswagen with Volkswagen PC1. Okay. Different ways to get the correlation. One way is to use the NumPy package, which we already loaded in. We called it NP. So NP has this function core coef, and we just have to give in what we want correlation to be with. So I just do some copying here. Yeah, just take the original Volkswagen return and give me its correlation with the PC1 projected or rotated Volkswagen return. Find a better name for that. All right. Please also print that thing. It's such a long name. Print. All right. Okay. Because you see the correlation is 45%. Okay. What else could we do? Just to make sure that the PC1 rotated Volkswagen return is really what we think it is. Let's just make sure that movements in that return have a perfect correlation with the market or with PC1, which we showed in the previous video coincide. So that is what we could do. Yeah. So I would just do the printout of that, and I just copy that entire thing here. Print out that. But instead of using the Volkswagen return, just take the market return. I should take PC1, but we already know PC1 has a correlation of 1 with the market portfolio, right? As you see, it's 1. The reason it's not 1 is just because PC1 had a 99.6% correlation with the market. There's a slight deviation from that. Yeah, same coefficient, very similar. So you really basically see that what the rotation did is you created a panel of our 42 blue chips that is only driven by market risk as of now. I said I don't yet have an application. The reason I just came up with it first, I was thinking about the scientist students from the informatics department, usually in our class, and I was thinking about this handwriting example. That's why I thought I need to find something to help me find an application. And here the application was, I was thinking something along these lines of markets are not predictable. They are so noisy. So why don't I try to get rid of this handwriting noise at first and just try to explain the signal? And that is kind of what I now created. I have this portfolio of 42 assets, which are only driven by this market signal. But I don't have some nice application. Maybe it comes up. Maybe you let me know if you come across something that we could do with that. All right. That is kind of all, I believe. What we could do is we could save the data for our upcoming ideas, because we're kind of done with first look at data. So let's just do some saving. We have pandas data frames. So let's just save RD first, right? RD pandas data frame. We've got that nice function to CSV. How shall we call the function? RSE50. We did some cleaning in order not to forget that that was SAP cleaning that we did. And we had some nuns which we got rid of. So it's the realized returns as of November 2020 CSV. Here you have it. And I also, oh, I see. Didn't I say that it's not a pandas? Then let's just see whether we can also use the same function to CSV. Okay, ES50 cleaned. It's not the realized one, but it's PC1 induced. I don't have a better name for that as of now. CSV, please. I knew it. It's a NumPy array. What's the thing? Isn't there not? dd dot to, shoot, I don't. How to get the NumPy to pandas? Isn't that it's just this command about, I mean, we don't need that anyways, so we don't need that anyways, but still, I know there was a command which allowed me to write a NumPy into the pandas, right? Let's just write that into the comments in the video, so we do it then next time. So, stay tuned, more stuff to come.